Good day. So for this video, we will be discussing area by integration. So say for example, we have here a curve. Okay. So this curve described by y as a function of x. And we want to know the area under the curve, okay, between the curve and the x-axis. So we want to find the area between, say, x is equal to a and x is equal to b. Okay, so say we are concerned with this area, so bound by the curve, the x-axis, and the limits x is equal to a and x is equal to b. So the idea of area by integration is that we divide the whole area into very small rectangular strips. Okay, so we will divide this with very thin, very small rectangular strips. Okay, so we're until x is equal to b. So from x is equal to a to x is equal to b, so we will divide them. We will divide the area into very thin strips. Okay, so this is very thin strips. Okay, so let's call say we take one strip here. Okay, and then let's have, say for example, our strip is, the width of our strip is delta x. Okay, so the thin strips where delta x approaches to 0, so that's how thin those strips are. Okay, so the width of the strips approaches to 0. Okay, so in integral calculus, so what we are actually doing is we will add all those rectangular strips. Okay, so taking one strip, so say for example, let's have this strip. Okay, so this strip, we take one strip. Okay, so its width will be dx. Okay, and its height, okay, so its height will be described by the graph, okay, for which y is equal to function of x. Okay, so since this is, so the length of the strip will correspond to y, okay, of this. Okay, so in solving for the area, so what we do is we add all the areas of those strips. Okay, so we add the areas of all those very small strips from x is equal to a to x is equal to b. Okay, so therefore its area now is equal to so the area of one strip is y dx. Okay, so that's the area of one strip. Okay, so since this is differential, so therefore since this is differential width, so we will be performing integration. Okay, from x is equal to a to x is equal to b. Okay, so that's how area by integration works. So what this means actually is that we are adding, okay, so we are adding all the areas of the strips. Okay, so the area of one strip will correspond to y dx. Okay, So we will add all those areas from x is equal to a to x is equal to b. Okay, so with this formula, okay, so let's say this is a formula. So this is the general formula for the area under a curve. Okay, so another method is, in this method we use a vertical strip. Okay, so we can also use a horizontal strip, so that will depend upon the problem and the given function. Okay, so this is a vertical strip. Let's take note of that. So what if we have a horizontal strip? Okay, so say for example this is our, let's draw another curve. So say our curve looks like this. Okay, so let's say this curve is x as a function of y. Okay, so from y is equal to a to y is equal to b. Okay, so the same process, we will be doing the same process wherein we will draw a strip, okay, that will represent the area of one strip. Okay, so again we will be dividing, the concept of integration is dividing this area into very thin strips. Okay, so taking one strip, so say for example this. Okay, so the length of the strip, okay, will correspond to x. Okay, so because the strip is along the x-axis, okay, it's parallel to the x-axis, therefore its length will correspond to x of this function. Okay, so this is x, and then this will be our differential in y. So since this is vertical, okay, the measurement of the width of the strip is vertical, therefore this is the y. Okay, so for a horizontal strip, so its area is equal to the integral of area of one strip is x dy, from y is equal to a to y is equal to b. Okay, so this is a general formula for a horizontal strip. Okay, so let's solve some problems so that we can apply those very simple formulas. So for our first example, so find the area bounded by the curve y is equal to 9 minus x squared and the x-axis. And we will solve this in two ways. Okay, so solving it in two ways means we will use a horizontal and a vertical strip. Okay, so for solving problems involving area, okay, so it is part of the solution is the illustration of the curve. Okay, so you don't need to show the exact proportions, okay, of the curve, but you must have a general idea, okay, of how the graph looks like. Okay, so here we have a curve of y is equal to 9 minus x squared. Okay, so upon looking at this, so you should already recognize that this is a parabola. Okay, so we have y, so y is equal to 9 minus x squared. Okay, so we must So since you've already recognized that it is a parabola, okay, so we must graph it, okay, we must sketch its curve. But for us to do that easily, so we might want to convert this first into standard form. Okay, so what are the standard forms? So if it is um, oriented horizontally, so opening to the right or to the left, okay, so then we will have y minus k squared is equal to 4p times x minus h. Okay, so this is plus or minus if it's oriented. So positive opening upwards, negative opening downwards. And then if it's opening, sorry, sorry, that was so y minus k squared is equal to plus minus 4p times x minus h. So it's positive it's if it's opening to the right, okay, the negative opening to the left. So positive, negative, so this is opening to the right, and if it's negative it's opening to the left. Okay, so it could also be x is equal to x minus h squared is equal to plus minus 4p times y minus k. It's positive if it's opening upwards, and it's negative if it is opening downwards. Okay, so we must transform this, okay, into any of these forms. So this is a review of your analytic geometry. So again, we have y is equal to 9 minus x squared. So since x is squared, okay, so it's either opening up or opening down. So let's transpose 9 on the other side. So y minus 9 is equal to x squared, okay, or x squared is equal to, sorry, that's negative x squared. Okay, so this is, so therefore negative x squared is equal to y minus 9, okay, and then dividing both sides by negative, so this will be x squared is equal to negative y minus 9. Okay, so therefore this is so similar with this form. Okay, so therefore this is opening downwards, okay, and then its vertex is at h is equal to 0 and k equals positive 9. Okay, so this is opening downwards, vertex at 0 and positive 9. Okay, so therefore we can now draw it. This is y, and then this is x. Okay, I'm sorry, so this is y, and then this is x. So it's a parabola opening downwards with vertex at 0, 9. So we have 0, 9 lies along the positive y-axis. So say for example it's here, so this is 0, 9, and then the parabola is opening downwards. Okay, so never mind my drawing. So this is supposed to be symmetrical. Okay, so however, we don't have the coordinates of the intersection, okay, of the curve with the x-axis. So remember that we are looking for the area bounded by the curve and the x-axis. So we are concerned with this area, okay, right here. So this area. Okay, so let us solve first for the these coordinates. Okay, intersection with the x-axis. So it should be, so solve for the x-intercepts. Okay, so at the x-intercept, y is equal to 0. Okay, so here and here, its coordinates correspond to y is equal to 0. So y is equal to 0, so we will have from here, so we have y is equal to 9 minus x squared. Okay, so at y is equal to 0, so therefore 0 is equal to 9 minus x squared. So factoring this, so this will become 3 minus x, and then 3 plus x is equal to 0. So equating the factors to 0, so this will become x is equal to 3 and x is equal to negative 3. Okay, so therefore the coordinates here and here, so this is positive 3, 0, so the other one is negative 3, 0. Okay, so why did we solve for the coordinates? Okay, so we solved for the coordinates because the coordinates are important, okay, in determining the limits. Okay, so for our first solution, okay, so we will be using a vertical strip. Okay, so again here, so we imagine that this whole area will be divided into vertical strips. Okay, okay, so say for example we have this strip. Okay, so since this is a vertical strip, so again from our formula, okay, as you can see, it's y dx from x is equal to a to x is equal to b. So here the strip, so we will have the length of the strip is y, its width is dx, and we are integrating it from x is equal to negative 3 to x is equal to positive 3. Okay, so therefore the area of this curve using a vertical strip is integral of y dx from negative 3 to positive 3. Okay, so expressing y now in terms of x, so y in terms of x will be given by the function. Okay, so y is equal to 9 minus x squared. So since y is equal to 9 minus x squared, so this will now become integral of 9 minus x squared dx from negative 3 to positive 3. Okay, so the next is, so actually here we can use the properties of odd and even functions. Okay, so from negative 3 to 3, so we just need to check if the function here is odd or even. Okay, so by inspection, so we can see that this is an even function. Okay, because so let me solve it here. So because if f of x is equal to f of negative x, okay, so therefore this is an even function. Okay, so our f of x is 9 minus x squared. So what is f of negative x? So that is 9 minus, replace x with negative x squared. So this will become, still this will become 9 minus x squared. So therefore this is an even function. Okay, so this is even. So instead of writing from negative 3 to 3, so we can just write it as 2 multiplied by the integral from 0 to 3, okay, of 9 minus x squared dx. Okay, so as you can also see, if we apply it here in our area, so if we only integrate between 0 and 3, okay, so that will be half of the area, so that will only be this one, right? Okay, from 0 to 3. But we have here a multiplier of 2, so if we multiply it by 2, then it will be the whole area, because these two halves are identical. Okay, so by using the odd or even function, so we can simplify, okay, the integrand. So performing the integration, so we have, so let me continue it here. So we have a is equal to 2 integral of 9 minus x squared dx from 0 to 3. Okay, so let's integrate that. So this will become 2, and then integral of 9 dx, that will be 9x minus integral of x squared, that would be x cubed over 3, okay, or 1/3 x cubed, okay, from 0 to 3. Okay, so substituting the limits, so we will have 2, okay, so we will be using curly braces, and then substituting the upper limit here, so we will have 9 times 3 minus 1/3 of 3 cubed, okay, minus 9 times 0 minus 1/3 of 0 cubed. Okay, so this will now become, obviously, this is 0, and this is also 0. Okay, so what will remain is 2 times, this will become 9 times 3, 27, minus 9 cubed is 27 divided by 3, so that is minus 9. So 27 minus 9 is 18 times 2, so this will become 36. Okay, and this is in square units, since this is an area. Okay, okay, so how about the second solution, where we are going to use, we'll be using a horizontal strip. So the first solution was a vertical strip, horizontal. Okay, so let's draw again the curve. So let's say it's like this, and then this. Okay, so what if we will be using a horizontal strip? Okay, so remember that a horizontal strip okay, is measured from the axis to the graph. Okay, so therefore, when we draw a horizontal strip, it's only from the axis until the graph. Okay, so we can only draw it like that. Okay, so it is from the axis until the graph only. Okay, so let's say this is dy, right? And then this is x. Okay, so our area now would be equal to the integral of x dy, okay, from y is equal to, so what's the y coordinate here? So this is positive 3, 0, and then this is 0, 9. Okay, if we have dy as our width of the strip, so for the limits, we will be using the coordinates of y. So here, it will be from 0 to y is equal to 0 to y is equal to 9. Okay? And with this, what we can actually solve is only half of the curve. Okay? So what about the other half? So similar earlier, so since this is a symmetrical figure, then the area on the left side is just equal to the area on the right side. So since here, this expression will only get the area of the right side, so all we need to do to get the total area is to multiply it by 2. Okay? So, that's it. So the next is express x in terms of y. We don't have that, okay, but we are given that y is equal to 9 minus x squared. Okay, so transposing x squared on the left side and y on the right side, so we'll have x squared is equal to 9 minus y. Taking the square root of both sides, so we'll have x is equal to square root of 9 minus y. Okay, or this can be also 9 minus y raised to 1/2. Okay, so substituting that x in terms of y, so we'll have 2 integral of 9 minus y raised to 1/2 dy from 0 to 9. Okay, so how do we integrate this? So we can integrate this using the general power formula, where our u is 9 minus y. Okay, so its du should be the complete differential of 9 minus y, that is negative dy. So here we only have dy, so therefore we need to add negative in beside dy, and to balance that out, so put negative outside the integral sign. So it will become negative 2 integral of 9 minus y raised to 1/2 times negative dy from 0 to 9. Okay, so we can now integrate that, so it will become negative 2 times, using the power formula, so this will become 9 minus y raised to 1/2 plus 1, so that is 9 minus y raised to 3/2 over 3/2. Okay, from 0 to 9. Okay, so continuing that on this side, so this is equal to negative, so if you multiply this will become negative 4 over 3. Okay, negative 4 over 3 times 9 minus y raised to 3/2 from 0 to 9. Okay, so substituting the limits. So for the upper limit, so let's take 4 over 3 on the outside, and then this will become 9 minus upper limit of 9 raised to 3 halves minus 9 minus 0 raised to 3 halves. Okay, so this will become 9 minus 9, so this will become 0, and then this will become, so negative 4 over 3 times, so this is 0 minus, so 9 raised to 3 halves, so 9 cube, I don't know, but I can first 9 square root of 9 is 3, and then cube, that is 27. Okay, so negative 4 over 3 times negative 27, so 3 cancel out 3, this will become 9, so negative 4 times negative 9, so that is still positive 36 square units. Okay, so we still obtain the same answer even if we use a horizontal strip. Okay, so but for the solution, okay, so it will be actually your decision on what strip are you going to use. Okay, so on what strip you feel like it's easier. Okay, so it will be up to you. Okay, so you should know what strip would you use. Okay, so that you can simplify your solutions, and of course avoid committing too much mistakes. Okay, so that's it for this lesson.